All right, so for problem 14, we are looking for the domain algebraically of this function. We have two different things going on that are important. One is we have a rational expression, so that means that this part right here cannot equal 0 overall. So that tells us that x cannot equal positive 5. We also have this radical expression, and so that tells us that that part, x squared minus 2x minus 15, is greater than or equal to 0. So I am solving an inequality. I have to factor to solve that inequality, and I can't factor to solve inequalities. That's with the inequality symbol, we just don't really know what to do with that. So I'm going to go ahead and change this problem to an equal sign. And I'm going to factor to solve it, and then I'm going to go from there. So to factor this, I'm looking for two numbers that multiply to negative 15, but add to negative 2. And the two numbers that do that would be negative 5 and positive 3. So I have x minus 5, x plus 3. Okay, so that means that the two x values that I have are 5 and 3. Sorry, 5 and negative 3. And at this point, I know that those are my values for x that would make the inequality equal 0. So I'm looking back up here at this inequality now. I know that those two values are the numbers that would make the inequality equal 0, but I want to check and see which values would make the inequality greater than 0. So I'm going to go ahead and draw a number line. I'm going to put negative 3 on my number line, and I'm going to put 5 on my number line. I know that I can equal negative 3 because that makes the inequality equal 0, and it can. I know that I can equal 5 because that makes the inequality equal 0, and I can. So now I just need to plug some other numbers in. And I'm going to choose a number first that's to the left, using all the colors today, to the left of negative 3, so like negative 4 would work. And I'm going to plug it in right here, and I'm going to plug it in right here. So for the first one, I have negative 4 minus 5 is a negative. For the second one, I have negative 4 plus 3 is also a negative. So a negative number times a negative number is a positive number. Next, I have to choose a number between negative 3 and 5. I can choose 0 because I'm lazy. So I'm going to go ahead and plug it into those factors again. 0 minus 5 is negative 5. That's a negative. 0 plus 3 is positive. A negative times a positive is a negative. Next, I'm going to go ahead and choose a number that's bigger than 5. So 6. 6 minus 5 is positive. 6 plus 3 is positive. And a positive times a positive is a positive. So again, I was choosing numbers. I chose negative 4, I chose 0, I chose 6. And I was plugging them in here and multiplying them together. All right, so I have to go back to that inequality. I am looking for numbers that make that inequality greater than or equal to 0. It equals 0 right here, and it's greater than 0 right here and right here. So I'm going to say that my inequality is greater than or equal to 0 when x is less than or equal to negative 3 and when x is greater than or equal to positive 5. So that is not the final answer to my problem. That is just the domain for that one piece of the original problem. So now what I need to do is I need to go back up here. I knew that one of my limitations was x could not equal 5. And then my other limitation is that x has to be less than or equal to negative 3 and greater than or equal to positive 5. So if I want to include both of those things at the same time, then I'm going to say that my overall domain would be x is less than or equal to negative 3, or x is greater than 5. Not equal to 5, because up there it says x cannot equal 5, so down here I know that I should scribble this out. Okay, so x is less than or equal to negative 3, or x is greater than 5. I could also write that as negative infinity to negative 3, 5 to infinity.